I'm going to bring before you 2 points over here. One is kinematical gravity, the other is gravitational gravity. It appears to be slightly surprising that gravity is gravity, but why we are classifying it as kinematical gravity and gravitational gravity? So let me brief about kinematical gravity here. You could see on the board over here, we take Earth's surface to be flat. Okay, and here if I take up under gravitational gravity, here Earth is taken as a small sphere, right? So when you make a comparison here at every point the gravitational field which I can represent it with a G, acceleration due to gravity, is uniform everywhere. Unlike over here, right? G represents the field, right? So G at different points will be directed in different directions, okay? But all are directed towards the center of the Earth. So because of this, what you find is a body which is moving will be behaving differently. Suppose I drop a body over here, right? When I freely release it, it is going to follow a straight line path. Suppose if the same body is projected horizontally, here it will follow a parabolic path. It's a parabola. Now when I come to the other side here, suppose if I am taking a tower over here, right, a tall tower from which if I start throwing the body with different speeds, for a speed which is very less, it follows elliptical path, falls to the earth. For a particular speed called as orbital speed, it will complete one circular path and comes back, okay? And if I further increase the speed, it moves in an elliptical path. If I further increase the speed, it moves in a parabolic path. And further, if I increase the speed, it moves with a hyperbolic path, like that. So looking into the field nature, the paths are defined, right? In a uniform field, there are only two possible paths, straight line or parabolic. Whereas in case of non-uniform field, something like this around the earth, right, different paths are possible. It can be a circle or an ellipse or a parabola or a hyperbola. Okay, so this is how we can talk about different aspects of the same entity called as gravity, right? So don't get confused when you are dealing with kinematics. You need to consider the field to be uniform, and when you deal with gravity, you should consider it to be non-uniform. So this is Ranganath signing up, and soon I'll be back with some more information in physics at different cases.